everyone, welcome to GEMCHEM. Now today's video is on Stereochemistry part 7 video, and here we are going to deal with conformations. Now in the previous video also we had dealt with the conformations, and this is the continuation of that video. Now before starting, if you are new to GEMCHEM, do not forget to subscribe the channel and hit the bell icon for regular updates. And already 6 videos of stereochemistry are uploaded in channel. You can watch it. I will give the link in the description box as well as the I button present above this video. Now let us start. Now first of all, today we will deal with the conformation of n-butane. And what is n-butane? If you remember, CH3, CH2, CH2 and CH3. Now we will take this as carbon 1 and this as carbon 2. Now we will start drawing. So this is our first thing. Now we will use the Newman projection for that. So suppose we consider CH3 is placed here, right? Here are the 2 hydrogens for the first carbon, and similarly at the back carbon there is CH3 present here, hydrogen is present here, and hydrogen is present here, and this is a fully eclipsed conformation. So since it is fully eclipsed, so it will have high repulsion between the 2 methyl groups present here. So this will be highest in energy, remember this. Now if we try to rotate it by an angle of 60 degree, okay, by an angle of 60 degree as we have seen in the previous video, so it will be like this. CH3, this carbon, front carbon will remain same, this back carbon will rotate by 60 degree. So here comes CH3, here comes hydrogen, here comes hydrogen. Next, on further rotation and total rotation of 120 degree, we will get another one, that is here we have CH3, here we have hydrogens, and the CH3 present here will come in eclipse conformation, here hydrogen and here another hydrogen, right? Now remember here, though in this one, that is, this is 1, this is 2, this is 3, though in 2 there is no particular complete repulsion, but there is a van der Waals interaction present here in the 3. So here is a presence of van der Waals interaction. Van der Waals interaction. Remember this. So it will be also higher but not as high as conformation 1. Right. Now if we try to rotate it by a complete angle of 180 degree, so it will become like this. That is, here is a CH3, here is hydrogen, here is hydrogen, and the down portion will have CH3, here will be a hydrogen, here will be a hydrogen, and this is the most stable one being anti. This CH3 and this CH3 is anti, right? So this is most stable one and it is the most lowest in energy. So this is number 4. Then we further rotate it by all total of 240 degree. Now what we get is this one. See, so here as it is CH3, hydrogen, hydrogen, here comes our CH3, here comes our hydrogen, and here comes our hydrogen, and this is our number 5. Now this is further rotated by 300 degree. So we get this. See, first carbon remains same, CH3 present here, hydrogen, hydrogen, and here now comes hydrogen, CH3 again back in position with van der Waals interaction present in between the 2 CH3s, right? So here will be van der Waals interaction present in this, and this is number 6. Next, on further rotation by 360 degree, we will get back the number 1 conformation, right? We will get back number 1. So remember, here we can see from the previous case, that is, this is highest in energy. Then comes the van der Waals interaction. So this conformation, that is 2, and the conformation 6 will be in same energy, right? And then if we see 3 and another one is 5, they look alike, so their energy is also present, right? And the last one, which is the lowest in the energy, will be 4. So let us draw the diagram. If we draw the graph like this, potential energy is present here, kilocalorie per mole, and here we have the degrees, that is 60 degree, 120 degree, 180 degree, 240 degree, 300 degree and 360 degree. So first one is highest in energy, so this is the highest point of energy, right? The next one for 60 degree rotation is down in energy rather than this one, that is number 1. So here is number 1, the next one is little decrease in energy, so it is number 2. Next comes our further one, that is partially eclipsed. So if you see the partially eclipsed conformation, there is also repulsion between the CH3 and H, right? So this is partial repulsion. So it is partially eclipsed, right? Partially eclipsed. So that will also increase the energy since eclipsed conformation, but not as high as we have seen for the case of 1, right? So it will come near about in between 1 and 2. So this is 3. Then we have our next one, that is 4, which is lowest in energy, that is 4. Next comes our again equivalent to 3, that is 5. So here is our 5. Next comes our equivalent structure, that is this one, 6. So we can write here with same position as that 2, it is 6. And ultimately on 360 degree rotation we get 1 back, right? So if we draw now, it will be like this. This coming here, going further down, this comes here and ultimately here. And if we know the energies, it will be like this. This from the level of 4 is 0.9 kilocalorie per mole. Similarly, the stage from here, it is about 36 kilocalorie per mole, and this is very much stable, right? So this was the conformation of n-butane. Now we will deal with the conformation of 2-methyl butane. 2-methyl butane, right? Now what is 2-methyl butane? CH3, CH, and here is our another CH3, then CH2, CH3. Now if we try to start drawing, then we will take this carbon, that is second carbon as 1 and this as 2. So this is the carbon, here is a CH3, here is a hydrogen, here is a CH3. And in the back carbon we have a CH3, a hydrogen and another hydrogen, right? Now we try to rotate it by 60 degree. Now what is this conformation known as? Fully eclipsed, right? Now on 60 degree rotation we get like this, that is here CH3, hydrogen, CH3, and the CH3 of back carbon comes in between these two, then hydrogen, then here also hydrogen. Now we rotate it by another 60 degree to give a total of 120 degree, right? And here we get like this, that is front carbon remains the same, CH3, hydrogen, this will be CH3, here comes another CH3, here comes the hydrogen, and here comes the hydrogen, that is this part. Here comes the hydrogen and here comes the hydrogen. Next, on further rotation by 60 degree, we get a total angle of 180 degree, right? Now, what is the conformation which we obtain is like this. That is, here is CH3, CH3, hydrogen, here we have right now a hydrogen, here we have CH3 and here we have hydrogen. Now we try to rotate it by another 60 degree. So we get a total angle of 240 degree, right? And it looks like this. CH3, CH3, hydrogen, here comes our CH3, here comes our hydrogen and here comes our hydrogen. And this will further be rotated by 60 degree to get a 300 degree, right? And it will look like this, that is, here first carbon remains fixed, CH3, CH3, hydrogen, and this comes in between CH3 and here is our hydrogen, here is our hydrogen. And if we rotate further by another 60 degree to give a 360 degree, then we will get back 1. So let us name them and then start drawing the potential energy diagram. So this is 1, this is 2, and this 2 is having van der Waals interaction, which we have seen previously, right? So here is our van der Waals interaction. This is number 3, and this is a partially eclipsed conformation. So this is partially eclipsed conformation number 3. So it will have higher in energy. Next, if we see for the fourth one, this will be our 4, 5, 6, and ultimately we will get back 1, right? And if you see this one, this has again van der Waals interaction, though it is anti to this one, this particular CH3, but it has van der Waals interaction. Next, we have fully eclipsed conformation again. So here in this particular compound, we are having fully eclipsed conformation 2 times, fully eclipsed. Next one, we have 2 van der Waals interaction, right? So 2 van der Waals interaction. So if you can see, we have like this, that is the energy of 1, energy of 1, which we have seen here, energy of 1 and energy of 5 is same, right? And also if we see partially eclipsed conformation, then their energy is high. So we have partially eclipsed conformation only 1 time, so it is 3. Next, if we focus into the van der Waals interaction, so 2 van der Waals interaction are present in 6, so this will be higher in energy rather than 3. We have 1 van der Waals interaction in 2 of the conformations, which is 2 and another one is this one, that is number 4. So we will draw the diagram accordingly, right? So let us start drawing. So this is our graph, and here we have 1. This is the potential energy axis, and we will draw the degrees here. That is, this will be 60, next will be 120, next will be 180, next will be 240, then 300, and then 360. Right. This is 1. Then we have here 2. This is 2. Next we have here 3. Next again in the same level it is 4. Next the 5 is same as that 1. So here we have 5, and in between 3 and 4 we have another one, that is our 6. Right, and again it returns to the position of 1. So ultimately if we join the graph, it will be like this. Somewhat different than others, right? And this is very important because this is different and this comes. So this much for today. Hope this was helpful. Thank you for watching. Do not forget to like, share, subscribe and comment.